Hi, hello everyone. I hope all are doing well. I hope I'm perfectly audible and visible to each and everyone present over here to watch this particular session. Anyway, a warm welcome all of you to the YouTube channel of Infinity Learned by Sri Chaitanya. It's me Surya, your chemistry mentor for this particular session. Okay, finally we are moving to the last part of this particular chapter, that is classification of elements and periodicity in properties. Right? So far we have discussed about the major topics. We will start from the periodic table, their classification. Then we will be moving to the periodic trends and different properties like atomic radii, metallic and non-metallic character, ionization enthalpy and electron gain enthalpy. Today in this particular session, we are going to discuss the topic electron affinity as well as electronegativity in detail. Hi Manoj, good evening. Okay, now let us start with the first topic, that is the electron affinity. Okay, what do you mean by an electron affinity? Let us see here. We can... Okay, anyway, thank you for your compliments, Manoj. Okay, electron affinity is defined as the energy released. The energy released when an electron is added to the valence shell of an isolated, neutral isolated gaseous atom, right? Whenever an electron is added to the valence shell of an isolated neutral gaseous atom, the energy should be released, right? That type of energy released is known as the electron affinity, right? Electron affinity. We can interchangeably use this electron gain enthalpy as well as electron affinity in a simple way, right? As you can see here, if I am taking an isolated gaseous atom, X atom here, while adding one electron here, it will form its negative ion, otherwise anion, right? At that time, it will release some energy. That energy is particularly known as the electron affinity. Clear? Hi Sonu, good evening. And also in the case of electron affinity, the unit is given as kilojoule per mole or kilocalorie per mole, right? Kilojoule per mole or kilocalorie per mole is the particular unit of this electron affinity. Then there will be some relationship between the electron gain enthalpy as well as electron affinity. As you can see here, this is the equation. The electron gain enthalpy delta HEG is equal to minus of EA. EA means our electron affinity, right? This is our electron affinity. Minus 5 by 2 into R into T, where R is the constant and T is the temperature in Kelvin. Clear? Okay, isolated means, Manoj, right? Isolated means there will be a single atom or there will be no special bond, right? It will be completely free. There should be any bond between the atoms, right? That is the isolated neutral atom. Is the thing clear, Manoj? Okay, this is the particular relationship between the temperature. Whenever we are taking the temperature at 0 Kelvin, okay, fine. At 0 Kelvin, what will happen to this equation? T will become 0, right? T will become 0, which means that the delta HEG is equal to minus EA. Clear? Delta HEG is equal to minus of EA. Otherwise, we can say that at absolute Kelvin temperature or absolute 0 temperature. This 0 Kelvin means absolute Kelvin temperature. At absolute temperature, the electron gain enthalpy is equal to the negative of electron affinity, which means that the electron gain enthalpy and electron affinity have the same magnitude, but their sign will be different. Clear? Now let us move to the periodic trend in a particular periodic table. We will start from the group. What will happen to the electron affinity whenever we move from top to bottom in a group? What will be the trend? As I already mentioned that there will be the same trend as that of the electron gain enthalpy, right? What will happen to the electron gain enthalpy whenever we move from top to bottom in a group? Electron gain enthalpy. Okay, in the previous session, we have discussed about the electron gain enthalpy. Electron gain enthalpy always decreases from decreases in a group from top to bottom, right? Similarly, in the case of electron affinity also, it will decreases, right? It will decreases. What will be the reason? As I mentioned here, on going down the group, the atomic radius and nuclear charge increases. Atomic radius and nuclear charge increases, right? With an increase in the radius, there will be the attraction, right? The attraction of the added electron by the nucleus decreases. That's why electron affinity decreases. Clear? Same as the electron gain enthalpy. As we move down the group, the size increases. As the size increases, the attraction between the electron as well as the nucleus decreases. So that electron affinity decreases. Clear? Yes. Fine. Now, what will be the trend in a period? Just opposite, right? Whenever we move from left to right in a period, the electron affinity always increases or gradually increases. What will be the reason? On moving across the period, what will happen to the size? Size increases, right? Size increases. The nuclear charge increases and the radius decreases, right? Sorry, radius decreases. Here the atomic number increases and the size decreases. Because of this, the attraction between the added electron and the nucleus increases, so that electron affinity also increases. Clear? Is it clear now? Okay, Manish, I will already added some questions based on this topic. I will give you the questions, right, after this session. Fine. Now let me move to the next property, that is the electronegativity. I hope electron affinity was clear for everyone. Now let me move to the next topic, that is the electronegativity. What do you mean by an electronegativity? We can say that this is a measure of relative tendency of an atom to attract the shared pair of electrons in a covalent bond, right? Shared pair of electrons towards itself in a covalent bond. What do you mean by the covalent bond? I think you will be discussing in your next chapter, that is chemical bonding, in detail about the covalent bond. I have given a brief idea that in the case of a covalent bond, two atoms will share same pair of electrons, right? For example, if I am taking here, this will be one molecule, that is hydrogen and chlorine. It will form a covalent molecule, right? HCl. Here, in our previous idea, we know that chlorine is electronegative in nature, which means that the chlorine will attract its shared pair of electrons towards its, right? Towards its. Otherwise, we can say that chlorine is electronegative in nature in the case of HCl molecule. Clear? What do you mean by electronegativity? Yeah, fine. Hi Harshit, good evening. Okay, I have already discussed about the electronegativity. Then we can say that all other properties like ionization enthalpy, electron gain enthalpy, electron affinity are decided by the isolated atom, right? But here in this particular case, this is not a property of an isolated atom, right? There will be a bond is formed between the atoms. It is formed by a covalent molecule, right? So that we can say that the electronegativity is not a property of isolated atom, right? Then we can say that if we are considering different molecules now, in the case of different molecules, the electronegativity of an atom will be different. The electronegativity of an atom will be different in different molecules. Then we can say that this cannot be measurable, which means that it has no particular unit. The electronegativity is not a measurable property. We can say that it is unitless quantity. But we should have an idea about the electronegativity, right? So that we are using some different scales to identify the electronegativity values. Let us see what are the different scales for measuring the electronegativity. Okay, as you can see here, these are the two different scales of measuring the electronegativity. Okay, these are the scales of electronegativity. There are two scales of electronegativity to measure. First one is the Mulliken scale, which means that the scientist Mulliken introduced the scale. According to his concept, the electronegativity can be calculated by using IE plus EA divided by 2. What do you mean by IE? IE is the ionization enthalpy and EA is the electron affinity, right? We have already discussed. According to Mulliken, the electronegativity is defined as the average of electron affinity as well as ionization enthalpy, or it is given by IE plus EA whole divided by 2, where this ionization energy as well as electron affinity should be taken in the unit electron volt per atom. Clear? Okay, next session onwards, so we will start our new chapter, that is redox reactions, on Monday onwards, right? Okay, this is all about the Mulliken scale of classification or the measuring of electronegativity. Now let me move to the next scale, that is the Pauling scale. Generally, this is the most important one or most generally used one to measure the electronegativity. What he has done, according to Pauling, he given equation to find out the electronegativity, that is electronegativity of two atoms A and B. The difference should be given as 0.208 into root delta, where delta value is given as here EAB minus half into EAA plus EBB whole raised to 1 by 2. What do you mean by this EAA and EBB? These are the bond dissociation energy. If you are considering a bond AA, then EA should be the bond dissociation energy of this particular bond. EAB is the bond dissociation energy of the bond AB. Similarly, it is the bond dissociation energy of AA. This is the bond dissociation energy of BB and so on, right? This will be the value of delta here. And here the point you have to be noted that this delta value should be in kilocalorie per mole. Kilocalorie per mole. Now, he again explained these things in different terms, that is chi A minus chi B. Chi A means this is the electronegativity. Chi A minus chi B is equal to 0.1017 root delta, where delta is kilojoule per mole here, right? That will be the difference here. It should be kilocalorie per mole, that's why it will become 0.208. If it is in the kilojoule per mole, it will become 0.1017 to root delta, where delta is same here. Clear? Is it clear? Then, according to Pauling, he has discovered that the electronegativity value of hydrogen is 2.1. According to its reference, he has concluded the electronegativity value of fluorine as 4. Clear? Is it clear now? Just let me know. Now we will be moving to the factors that affect in the electronegativity. As we already mentioned in every properties, these are the main factors that affect in the electronegativity. As you can see here, as the atomic size increases, there is no need to explanation, right? We have already discussed about the atomic size. As the atomic size increases, there should be a decrease in the electronegativity, right? Which means the atomic size is inversely proportional to the electronegativity. Clear? The second factor which is affecting the electronegativity is the hybridization or the S character. You will be discussing on the next chapter, that is chemical bonding, about the hybridization, right? We have three types of hybridization. Mainly we are focusing on the three types of hybridization, that is sp, sp2 and sp3 hybridization. Whenever the S character on the hybridization increases, what will happen to the electronegativity? It will decreases, right? There will be a directly proportional relationship. S character is directly proportional to the electronegativity. As you can see here, in the case of sp hybridization, 50% of S character is present, right? 50% of S character is present. And whenever we are moving to the sp2 hybridization, there will be 33.3% of S character, right? Then for sp3 hybridization, it is around 25% of S character. Whenever the S character increases, the electronegativity also increases, right? Clear? Now let me move to the next factor which is affecting the electronegativity, that is the screening effect. We already mentioned, right? Screening effect. What will happen to the screening effect? What will happen to the electronegativity whenever the screening effect increases? Inversely proportional, right? Which means as the screening effect increases, the electronegativity decreases. Clear? The last factor which is affecting the electronegativity is the magnitude of positive charge on the ion. Magnitude of positive charge on the ion, which means that as the magnitude of positive charge on the ion increases, the electronegativity also increases. There is a directly proportional relationship, right? This factor is directly proportional to the electronegativity. For example, if I am taking an example here, if I am taking Fe2 plus and Fe3 plus, which one has the maximum electronegativity? Which one has the maximum electronegativity according to this particular factor? Hi, good evening. Hi, Oxen. Okay, what will be the answer? If I am taking two ions here, Fe2 plus and Fe3 plus ion, which one have the maximum electronegativity? Fe3 plus, right? As the charge on the ion increases, the electronegativity also increases. That is a directly proportional relationship there, which means that compared to Fe2 plus, the electronegativity should be maximum in the case of Fe3 plus, right? Clear? Now let us move to the general trend in the periodic table. What will happen to the electronegativity whenever we move from top to bottom in a group as well as left to right in a period? We will be discussing along with the atomic radius, right? Whenever we move from top to bottom in a group, what will happen to the atomic radius? Whether it is decreasing or increasing. While moving from top to bottom in a group, atomic radius increases, right? Atomic radius increases. Atomic radius increases, which means that the attraction between the electron as well as nucleus will be decreases, right? Will be decreases, which means that electronegativity decreases, right? Clear? Electronegativity decreases according to the atomic radii. Is it clear? Similarly, what will happen in a period from left to right? Whenever we are moving from left to right in a period, what will happen to the atomic size? Decreases, right? Whenever we move from left to right in a period, atomic radius or atomic size decreases, which means that there will be a strong hold of nucleus towards the electron, which means electronegativity also increases, right? The attraction to the shared electrons towards itself is known as the electronegativity, right? Electronegativity is the ability of an atom to attract the shared pair of electrons towards itself, right? Whenever size decreases, no, there will be a strong attraction. That's why electronegativity increases there along a period. Clear? Okay, you can see here the table of values of the electronegativity of representative elements. This is not B block, this is P block. Okay, this is P block, starting from group 1, 2, then 13, 14, 15, 16 and 17. This is the group 17. Right? Group 17. As you can see here, in the case of first group elements, what will happen to the group moving from hydrogen to lithium, sodium, potassium, rubidium, cesium? What will happen to the electronegativity values? Decreases, right? It decreases. According to the general trend. Similarly, in the case of second group also, from beryllium to barium, it will also decreases. As you can see here, in every group, the general trend, it follows the general trend, which means that electronegativity decreases down a group, right? And there is a most important thing you have to note that in the case of group 70 elements, right, halogens, these are the specific electronegativity values. In the case of fluorine, this is the 4 maximum value, right? In a particular periodic table, we can say that fluorine is most electronegative atom. Okay, fine. Is the board is visible now? Nilesh? Whenever we are considering the halogen groups, you can say that while considering all these values, you can say that fluorine has the most high electronegative value of around 4, right? Fluorine is the most electronegative element. Then what will happen to the period? Along a period, we will move from left to right. If you are considering the second period, starting from lithium To beryllium, this is 1.5, 2, 2.5, 3, 3.5, 4, which means that it follows the general trend, right? It follows the general trend. Along the period, what will happen to the electronegativity? It will increases, right? It will increases. While considering all these elements, you can say that fluorine is the most electronegative element having the electronegativity value of 4. Similarly, cesium, you can see here, cesium having the value of 0.7 is the least electronegative element along the period, along the whole period table, right? Clear? Is it clear? Again, one more exception is there. Whenever we are moving from top to bottom in a group, what will happen to the electronegativity? It should be decreases, right? While checking the second group elements, the 13 group elements, group 13. 13 group elements, you can see that boron, aluminium, gallium, indium and thallium, right? This is thallium. In thallium, it shows that generally it should be decreases, but you can see here that from boron to aluminium, it decreases, then it again increases, right? There is a specific reason that this is a poor shielding effect of d electrons, right? It is due to the poor shielding effect of d electrons. Clear? Then I have a question for you. If you are considering along a period, which group of elements have the maximum electronegativity? If you are considering in a period, you can check with any of the period here. Which group of elements have the maximum electronegativity along a period? Whether it is group 13 elements, 14 elements, 15 elements, 16 elements or 17 elements. Just look into the values of electronegativity here. You will get the answer. Hi, hello, good evening. Okay, what will be the answer? Okay, if you are considering the second period, right? Lithium have the least value of 1, then fluorine has the maximum value of 4, right? Again, in the third period, chlorine has the maximum value. And for fourth period, it is bromine. Fifth period, it is iodine. Last period, it is astatine, right? Which means all the halogen elements or the group 17 elements have the maximum electronegativity along a period. Is the thing clear? Now, let me move to the applications of electronegativity. There should be electronegativity values, right? According to a polling scale, whenever the elements with the electronegativity values are 2 or more, as you can see here, these elements, right, 2 or more, these are considered to be non-metals. For example, if I am taking here carbon, nitrogen, oxygen, fluorine, right, having the electronegativity value greater than 2, around 2.53, 3.54, these elements are considered to be non-metals, right? This is the first point you have to note it. The second one, electronegativity may be related to the chemical reactivity of a particular element, right? If we have the maximum value of electronegativity, this will be the most reactive element, right? That is, the chemical reactivity of an element is directly proportional to their electronegativity value. The element which has the maximum value of electronegativity should have the maximum reactivity, right? For example, fluorine is the most reactive element having the electronegativity value maximum of 4, right? 4. This is the electronegativity value of fluorine. Similarly, helium is the least reactive element. Helium is the least reactive element, right? In the case of reactivity, we will say that helium is the least reactive element. And also, if we are having the two elements having the same electronegativity value, what will be their chemical reactivity? Whether it is same or different. Whether it is same or different. If you are looking here, you can say that germanium and tin, right? Germanium and tin having the same value of electronegativity, right? 1.8, which means that these two elements have the same chemical reactivity. It belongs to the same group, right? Clear? Then, third point of application of electronegativity is that if we are aware of the electronegativity difference, we can predict whether the bond is ionic bond or not, right? Whether it is ionic bond or not. For example, if the difference in electronegativity is 1.7 according to Pauling scale, if it is 1.7 or more, the bond formed is generally an ionic bond. The bond formed generally is an ionic bond, right? Whenever we are given the electronegativity value, if the difference in electronegativity of the two atoms in a particular molecule or the compound, if it is 1.7 or more, we can consider this bond should be ionic bond, right? Clear? Similarly, we can predict the ionic character as well as covalent character of a particular bond according to the difference in electronegativity. The same, whenever the difference in electronegativity between the bonded atoms is 1.7, then it means that the chemical bond has 50% of ionic bond as well as 50% covalent bond. Covalent character, right? Clear? Is the thing clear? Just let me know so that I can move to the next topic. Yes, fine. Anish, thanks for the confirmation. So far we have discussed about all the properties, right? Starting from the atomic radii, then we move to the metallic as well as non-metallic character. Finally, we move to the ionization enthalpy, electron gain enthalpy, and finally, today in this particular session, we have covered the electronegativity as well as electron affinity of a particular period table, right? I'm generally just giving a whole summary of we have covered about the periodic trends. As you can see here in the particular periodic table, whenever we move from left to right in a period, electron gain enthalpy increases, right? Ionization enthalpy increases, atomic radius decreases, and electronegativity increases, right? And also the non-metallic character increases from left to right in a period and metallic character decreases, right? Clear? We have covered all the properties in detail in the previous sessions. Is it clear? Now let us practice some questions based on the particular topic we have covered today. Here is the first question for you. In a period from left to right, electron affinity, what will happen to the electron affinity? What will be the answer? Electron affinity, what will be the answer? Yes, Loria. Option A. Option A, right? Option 1. It increases, right? Clear? Yes, I am a Malayali. How do you know that? Varada? Okay, here is the next question for you. The Pauling's electronegativity is based on which property? Options are given here: electron affinity, ionization potential, both ionization potential and electron affinity, and last one is it is the bond energies. What will be the answer? Option 3. Okay, any other options? Let us check whether it is right or wrong. Any other options? Read the question properly. It shows about asking about the Pauling's electronegativity. Pauling's electronegativity. Okay, I will give you the answer. That is option 4 will be the correct answer, bond energies, right? These ionization potential and electron affinity related to the Mulliken scale of electronegativity, right? Hi Suhani. This is related to the Mulliken scale of electronegativity. We will be discussing about the Pauling scale of electronegativity, right? There will be a particular equation to find out the electronegativity difference. According to this particular equation, we will be dealing with the bond energies, right? Clear? Option D, option 4 will be the correct answer here. Is it clear now? Here is the next question for you. The electronegativity value of chlorine and bromine are respectively 3 and 2.8. What will be the formula of a binary compound formed between these two atoms? Option D. Any other options? Suhani, I will be discussing about the grade 11 chapter, that is classification of elements and periodicity in properties. Last 4 classes we have discussed about the genesis of periodic table, starting from the Dobereiner triads, modern periodic table and so on. Finally, we move into the periodic properties in a periodic table, including from atomic radii, ionization enthalpy, electron gain enthalpy. Now we are discussing about the electronegativity and electron gain enthalpy, electron affinity also, right? This is the most important inorganic chapter in the grade 11. Okay, option A will be the correct answer here. I will give you the explanation. Here it is given that chlorine and bromine is the atoms, right? What will be the electronegativity value of chlorine here? Chlorine having the electronegativity value of 3 and bromine having the electronegativity value of 2.8, which means that we have to be noted that whenever the electronegativity value is small here, if the two atoms having different electronegativity, if the atom that one having the least value of electronegativity should be considered as the central atom, right? It should be the central atom and it will be the first ion forming. Then the next one, which means BrCl. This will be the compound. I think you have studied in your grade 10 classes about writing the chemical formula of a compound, right? Bromine is always having the valency of -1. Chlorine is always having the valency of -1. Whenever we are cross over the valencies, we will just write it as Br1Cl1, right? Or simply we can say this chemical formula as BrCl. The point you have to be noted that whenever it is the electronegativity values given here, the one with having the least value of electronegativity should be written as the first element, right? Here it is bromine, which means option A, option 1, BrCl is the correct answer here. Is it clear? My Hindi is not that much good, that's why I am not explaining in Hindi. Okay, this is the next question for you. What will be the reference element for Pauling's electronegativity? What will be the reference element for Pauling's electronegativity? What will be the answer? We have already discussed, right? Option A, right? According to Pauling's electronegativity, he has concluded that hydrogen has an electronegativity value of 2.1. According to its reference, he found that fluorine has an electronegativity value of 4, right? Clear? We have already discussed. Here is the next question. In a period, electronegativity is highest for which group elements? Whether it is chalcogens, whether it is halogen, if it is inert gas or alkali metal. Option 2 is the correct answer, that is halogens, right? Which means group 17 elements. As I have already mentioned in the table of elements, right? You can see that whenever we are considering from the second period elements, you can see that fluorine has the maximum value of electronegativity, right? So that we can say that along a period from left to right, the electronegativity is highest for halogens or group 17 elements. Then what do you mean by a chalcogen? Which group elements will be that called as chalcogens? Anyone? Logesh. Group 18 elements are known as noble gases or inert gases, right? Okay, I will say chalcogens mean group 16 elements, right? Starting from oxygen, that is the oxygen family. Clear? Then alkali metal groups means it is the group 1 elements. Clear? Yeah, Logesh, you are right. The next question. The pair of elements with equal values of electronegativity is. Just give me a random guess, because I know that you don't know the exact value of electronegativity, right? Just give me a random guess. Option 1, right? Beryllium and aluminium. As you can see here, beryllium has the value of 1.5. Similarly, aluminium has the 1.5. You will be discussing about this property as diagonal relationship in detail in the next slide, so that you can get the correct answer. So here, beryllium and aluminium, that is option A will be the correct answer. Clear? Having the same value of electronegativity, chi is equal to 1.5. Are you getting my points clear? Now let me move to the next topic, that is the nature of oxides. Based on the nature, the oxides are classified into 4 types. What are they? First one is the basic oxides, acidic oxides, amphoteric oxides and neutral oxides. These are the 4 types of oxide. Basic oxides means it will react with acids. Similarly, acidic oxides will react with bases. Amphoteric oxides means they will react with both acids as well as bases. Neutral means there will be no reaction between the acids as well as bases, right? Now, we should have an idea about the complete periodic table in which type of elements will show the basic as well as acidic as well as amphoteric oxides and so on, right? Elements on the 2 extremes of a period, from the left or right, it will combine with oxygen to form oxides. And in a particular period or periodic table, we can say that the normal oxide formed by element on the extreme left. Which are the groups in the extreme left? Extreme left means this side of the periodic table, right? Group 1 and 2 elements. It will form the most basic oxide. Most basic oxide. For example, the extreme left, sodium is one of the elements, right? It will form the most basic oxide, Na2O. Then, what will happen whenever we move to the extreme right? Whenever we move from extreme right of a periodic table, which means the p block elements, right? Towards the right, group 16, 17, 18, it will form the most acidic oxides. Most acidic oxides. For example, chlorine. Chlorine is the element which is present in the most extreme right of the periodic table. So that we can say that Cl2O7 is an example of acidic oxides. Otherwise, we can simply say that the basic oxides are formed by metals and acidic oxides are formed by non-metals. Then, whenever we are moving to the center of the periodic table, right? Whenever we are moving to the center of the periodic table, it will form the amphoteric as well as neutral oxides. Amphoteric as well as neutral oxides. For example, if you are considering the carbon nitrogen elements, we can say that it will form the neutral oxides like CO, carbon monoxide, nitrogen oxide, NO, and N2, nitrogen dioxide, nitrous oxide, right? For example, Al2O3 and As2O3 are the examples of amphoteric oxides, which means that it will react with both acids as well as bases. Clear? Here is a table given for you. This is the nature of trioxides formed by group 15. As you can see here, nitrogen, right? Nitrogen, phosphorus, arsenic, antimony and bismuth. Nitrogen is a non-metal. As I already mentioned that all the non-metals are forming acidic oxides, right? N2O3 and P4O6 are the examples of acidic oxides. Similarly, the center of the periodic table, it will form the weakly acidic or amphoteric, right? Weakly acidic or amphoteric oxides. For example, arsenic and antimony. Arsenic and antimony, they are the metalloids. It will form weakly acidic or amphoteric oxides. For example, here. Then last one, bismuth. It is a metal. Belongs to the extreme left of the periodic table. It will form the basic oxide. Now we are moving to the oxides of elements in the third period. As you can see here, group 1, that is a sodium, group 2 magnesium. These are the extreme left, right? Extreme left, or they are the metals. These metals are forming the acidic oxides. These are forming the acidic oxides, right? Sorry, these are forming the basic oxides. Extreme left. In the center of the periodic table, you can see that group 3, 4, 5, they are forming amphoteric or weakly acidic oxides like aluminum, silicon, phosphorus. And towards the extreme right, it will form the acidic oxides. Example, Cl2O7, HClO4, SO3, H2SO4 and so on. Clear? Finally, we will be moving to the anomalous properties shown by the second period elements. What are the second period elements? That is, the elements of second period exhibit anomalous behavior like lithium. Lithium in the group 1 is belongs to second period, beryllium in group 2 and boron to fluorine in group 13 to 17. They are shows very anomalous behavior as compared to other elements in the same group. Why this happen? Because of their high electronegativity, small size and absence of d orbitals and large charge by radius ratio. These are the 4 reasons to be for the second period elements which shows anomalous behavior. Clear? The next one is the most important property that I already mentioned about the diagonal relationship, right? Whenever we are discussing about the electronegativity values of beryllium and aluminum, I have already mentioned that it has the same value of electronegativity around 1.5, right? This is because the diagonal relationship. The lighter elements of the second period resemble in their properties with those of third period element which is placed diagonally to each other. For example, this is the second period element, right? Lithium, beryllium, boron and carbon belongs to the second period. And sodium, magnesium, aluminum and silicon belongs to the third period, right? According to the diagonal relationship, it says that every element present in the second period has the similar properties, resemblance to that of the element in the third period which is diagonally placed each other. For example, here lithium shows the resemblance in properties with magnesium, beryllium with aluminum, boron with silicon. Right? Clear? These are the diagonal relationship. As you can see here, the values are also given here. In the case of metallic radius, lithium and magnesium having almost similar 152 or 160, almost similar metallic radii. Similarly, in the case of beryllium and aluminum also, there will be the resemblance in properties like ionic radii, atomic radii, metallic radii and so on. Clear? And also the point you have to note that the diagonal relationship is applicable only up to third group elements or group 13 elements. Clear? Hi Ananya, good evening. Fine. Now let me move to some practice questions here. Here is the first question for you. The oxide that is most acidic is, the options are given here. First one Cl2O7, SO3, P4O10 and N2O5. Which one is the most acidic oxide formed here? What will be the answer? Option 1, right? Cl2O7. That is, non-metals are formed by the acidic oxides are formed by the non-metals. Acidic oxides are formed by the non-metals. For example, you can see here Cl2O7 is the one having the most acidic oxide. Therefore, option A is the correct answer. Here is the second question for you. Generally, the nature of non-metal oxides is whether it is acidic, basic, amphoteric or neutral. What will be the answer? Option B, right? Option 2 or acidic. Non-metal oxides are commonly known as the acidic oxides. Okay, here is the next question. The diagonal relationship phenomenon is not observed after. The diagonal relationship phenomenon is not observed after which group? Whether it is 1A group, 2A group, 3A group or 4A group. The 1A group stands for group 1. Then 2A group stands for group 2. 3A group stands for group 13. 4A group stands for group 14. What will be the answer? Option 4, right? Group 14 elements. Till group 13 elements, it shows the diagonal relationship between the elements present diagonally to each other. Only the group 14 will not show the diagonal relationship, which means option 4 will be the correct answer. Yes, Anish, clear. Option 4 is the correct answer. Okay, that's all about from my side for today. I hope you guys enjoyed the session for today. So far we have covered the complete chapter, that is classification of elements and periodicity and properties. I hope I have covered all the most important topics from the particular chapter. And the next session onwards we will come with the new chapter from the physical chemistry, that is the redox reaction. And don't forget to press the like button, share the particular session to your friends, and also do subscribe our particular channel for more updates. And see you soon on the next session on Monday, the same time. Till then, bye bye, take care, good night all of you.